Okay, Algebra 2 students, here's the first video for section 4.2, graphing rational functions. They're going to show us a few different strategies. In example 1, they're going to show us how to rewrite a rational function to identify the asymptotes. I typically don't use this strategy, but we'll give it a shot. 4x over x minus 3, we're going to rewrite that using long division and then relate it to 1 over x. So when you divide 4x by x minus 3, okay, you get 4. 4 times x is 4x, so 4 times x minus 3 is 4x minus 12. 4x minus 4x is 0. Negative 12, but then it's the negative of negative 12, so that's positive 12 is your remainder. And the reason why I had to do long division is that it comes out like this, which you can relate to the parent function of 1 over x. It's been translated over 3 units to the right and 4 units up, and has a vertical stretch of 12. That's what they wrote right here, and then they graphed it. To graph it, after doing the x and y asymptotes, because of the shift, 3 units to the right and 4 units up, that's where the asymptotes shifted. I would have plotted some points. I wouldn't know exactly. I know stretching by a factor of 12, but I wouldn't know exactly where that curve would end up. So I'm going to show you, I'm going to plot points when I get to that point. All right, they already have one for us to try. Maybe watch this one, or if you want, you can click pause and give it a shot yourself. Long division, 6x, I think I already have it set up over here. All right, we're going to take 6x and we're going to divide that by 2x plus 1. I kind of already know what's going to come out of this. 6x divided by 2x is 3, so I know it's going to be 3. And when you multiply by 3, you get 6x plus 3, but now you need to subtract, so you end up with negative 3 as a remainder. So that means it's a minus 3 over 2x plus 1. So this is another way to write the original function. This is another way to write this function. And the reason to do that is that we can see, we're going to have we have 2x plus 1, so that can equal 0. So that means the x asymptote is at negative a half, right? If I set the denominator equal to 0, x cannot equal a negative a half, or x equal negative a half is the asymptote equation. And there's been a vertical shift of positive 4, so I know y equals, did I say 4? A vertical shift of 3, so I know it's gone up 3 units. So I have negative 1/2, and I have 3 are the 2 asymptotes. So let me move that over to negative a half and positive 3. There, I think that would be pretty close. Maybe not that close. There we go, negative half and positive 3. Now I still got to know where the curve goes, so I would plug in some points. Since I'm over here, I'm going to plug in 0 and see what that comes out to. Since 0 is not on the asymptote, I can plug it in. 0 over 0 plus 1 is 0, so I know it goes through 0. I know it goes through 0, 0. So that's over here, which seems strange because here I am. It's because of the negative. We haven't talked about this yet. Because of the minus 3. Because of the minus 3, these asymptotes don't end up here and here. They end up over here. So it goes through 0, 0. And let me plug a point over here, like negative 2. If I plug in a negative 2, I get negative 12. Negative 2 is negative 4. Negative 4 plus 1 is negative 3. So I get negative 12 over negative 3, which is 4. So if I'm at negative 3, I'm at, and I already forgot, 4, I believe I said. So I can plot that right there. I would play, since you don't have this option of moving using the Desmos, but so I would plot in more points to find out the curve, because all I really knew is this one dot. Let's check with the answer they have. Yeah, I think that's about what I have. Yep, negative 2, 4. And they didn't go with the 0, 0, but I went through 0, 0. And they want to know the equations of the asymptotes. So it could be rewritten like this. I had that, and those are the 2 asymptotes. All right, let's give another one a shot. X over x minus 6. click pause, give it a shot, come on back. X divided by x minus 6. This is going to come up to 1. And when I multiply by 1, I get x minus 6. But then when I subtract, I get positive 6 as a remainder. So 1 plus positive 6 is a remainder of the x minus 6. So here it is rewriting it in that form. That means one of the equations of the asymptotes, because of this, is y equals 1. And another one is if this equals 0. So that means x equals 6 is another equation of an asymptote. So let me go back to the Desmos to graph that. 6 and 1. X equals 6. I need to zoom out. X equals 6. And y equals 1. So that brings it up to here. Now I need to know where to move these. Let me plug in a point. Since I'm over here, let me plug in 5. Plug in a 5. I get 5 over 5 minus 6, which is negative 1. 5 over negative 1 is negative 5. So at 5, I'm at negative 5. And then I would plug in 0. I know it already goes through 0, but I would plug in 0 and get that it goes through 0. That gives you 2 points to maybe sketch a curve. Probably need to go with more than that. And let me plug a point in over here. Let's see if I can move this first. All right, let me plug in, I don't know, 6. 6 over, oh, 6 isn't going to work. 7. 7 over 7 minus 1, 7 minus 6. 7 minus 6 is 1, so I have 7 over 1 is 7. So at 7, it equals 7, which is right there, which doesn't make sense. So I just did something wrong. Let me double check that. 7 over 7 minus 6. Oh, 7. That's not 7. 7's way up here. 5, 6, 7. Here we go. That looks better. All right. Kind of rough. They don't, with the Desmos, it's a lot easier because this function moves around as you, the whole curve moves around, so you don't have that option probably. Here are the problems for you to try. 13, 14, 15, and 16. That's it for this video. Have a great day.